Hey guys, welcome back to Knotty Thoughts. Today, I thought we'd go over everyone's favorite subject, tooling, specifically CNC tooling. Anything I say today is based upon my experiences or something I've read. If I misspeak or if I say something that is incorrect, please feel free to correct me. One of the most common occurrences that I run into is somebody who is looking for their first CNC and looking for some advice, or somebody who's just bought their first CNC and needs some help with tooling. Tooling on a CNC can be pretty daunting, and one of the things that seems to be missing when a lot of manufacturers sell machines is to cover the tooling. And the tooling is probably one of the more important aspects of your CNC. So today we're going to be going over that and kind of the basics, kind of an introduction. Before we jump into tooling, I need to start on the router itself. Now, on the router, there's a big motor called a spindle. That motor is essentially the same as the motor that's inside your hand router. That spindle holds the tool holder. The tool holder then holds the tool. There's really two main types of tool holders. There's what's called the ISO cone and the HSK. The ISO cone is seen as a more economical option, but it has a little less holding power. For our industry, the holding power of an ISO cone is more than sufficient. Now, I should also point out that the ISO cone is sometimes also referred to as the BT. I don't know what the BT stands for. Maybe somebody can comment in here and educate me. The most common type of ISO cone is the ISO 30. That 30 refers to the taper angle on the cone. There are ISO 45s, ISO 60s, ISO 80s, and so on and so forth. It's all dependent upon the manufacturer, the taper angle they choose, and then sometimes the tooling application. On top of the ISO cone, there's a thing called a pull stud. Now the pull stud is what the spindle itself actually grabs onto. Pull studs come in all different shapes and sizes, and they vary based upon the manufacturer. So whenever you're buying ISO cones or just buying individual pull studs, you want to make sure that you're buying the one that fits your manufacturer. More than likely, if your CNC spindle doesn't use an ISO cone, it uses something called an HSK. Now, I'm going to do my best, but HSK actually stands for German, Hohlschaftkegel. Now that roughly translates to hollow taper shank. I actually happen to have an HSK tool holder on me, and as you can see, that is a hollow taper shank. And that's the big difference between the ISO cone and the HSK. On an ISO cone, there's a pull stud, and the nose cone grips it from the outside. And on an HSK, the nose cone goes inside, expands, and that's what holds the tool holder in place. So that's the big difference between the tool holders. Before I move on, I want to point out that both tool holders are available in steel and stainless steel. Most of your shops are going to be in humid environments, dusty, got sawdust everywhere, and they're not great places for steel as steel corrodes. So a lot of people choose to spend the extra money and purchase a stainless steel tool holder. In front of me is the HSK tool holder we just talked about, but I want to move on to the top of it. In the spindle, this will actually be the bottom, but the top of it is called a collet nut. There are two different types of collet nuts, ones without stainless steel ball bearings, which I personally don't recommend, and ones with stainless steel ball bearings. If you look real closely, you can see the inner ring of this collet nut is spinning, and it feels pretty smooth. When you're securing a bit by tightening the collet nut, you'll want to use a torque wrench. Too often do I see people use a wrench without a torque gauge. You could over-tighten the collet nut, which would either damage the collet nut, the tool holder itself, or cause problems with the bit. When you do use a torque wrench, you'll want to make sure that your torque wrench is set correctly. Different manufacturers recommend different feet-pounds of torque. You should also take into consideration the tool you're running, the feed speed you're running at, and your spindle RPM. I just said there were two types of collet nuts, the ones with ball bearings and the ones without. However, there's also styles. If you look at this collet nut, there's little slots going around the outside. These slots are what the wrench fits inside of in order to tighten this on or loosen it from the tool holder itself. The collet nut itself is going to have varying slots based upon whatever the manufacturer chose. The style of the collet nut is actually what refers to the style of wrench that it's using. This right here is called a slotted collet nut or a multi-slotted collet nut. For this one, the wrench would have 4 prongs that fit into one full side of the collet nut. However, if the manufacturer only chose to drill, let's say 4 slots instead of the 6 like this, we would need a hook. So there's the slotted or multi-slotted, there's the hook, and there's also the hex. In the CNC world, you're probably not going to run into the hex very often, but it's still there. We've gone over tool holders and the collet nuts that go on them. Most often, people are going to refer to this entire unit as a tool holder, and usually people will order them together. There are a couple instances where I would actually order them separate. Probably the most common one is when one becomes unbalanced or damaged. Typically, your CNC spindle will be spinning between 16 to 18,000 RPM, dependent upon the application as well as the horsepower of your spindle. Imagine that spindle was the rear axle on your car and your wheel was out of balance. You'd feel it pretty well going down the road. The same goes for your CNC. These two pieces are machined to a highly precise balance so that your spindle isn't wobbling when it's going 18,000 RPM. Unfortunately, it's been too often that I see somebody take this out to change the tool out and drop one or both pieces on the floor. A lot of times you will end up seeing a little divot in the body of the tool holder or the collet nut, which is where they had to drill a little piece of material out in order to balance it properly. Earlier I mentioned that this is an HSK tool holder. More specifically, it's an HSK 63 tool holder. I'd like to throw out a challenge and ask you guys what the 63 stands for. The first person to comment this on the YouTube channel or within Facebook, and I'll check the timestamps, I'm going to send you something from this demonstration. Beyond the HSK 63 specification, there's another level of detail to pay attention to, and that is the collet size. This is a collet. Specifically, this is an ER32 collet. Now, this collet nut is an ER40 collet nut. I'm going to do this gently, but if you watch, the collet goes through the collet nut. Collets are machined to extreme precision, just like tool holders and their collet nuts. This collet here, the ER32, is made out of spring steel just like any other collet. For some reason, people seem to forget that spring steel loses its spring. Something interesting I've learned over my career is that information on spring steel and the quality of the steel seems to be difficult to find. Everything that I've found that explains the lifetime duration of spring steel seems to come from a long time ago. I'm talking 70s and 80s. What I have been able to find is a lifetime expectancy of this spring steel under pressure. Usually that's demonstrated in hours or hours of clamping. The reason I mention that the information is decades old is because back then CNCs didn't have tool changers. You may have had a few tool holders in order to keep one tool ready, but every time the machine needed to change tooling or change the operation that it was doing, you had to manually swap out the tool holder. There is some information available on the lifetime expectancy of spring steel based upon its quality and grade. Now, it tends to vary quite a bit dependent upon the manufacturer and the person publishing the information, so I'm not going to get into an argument about that. What I am going to discuss is simply my recommendations for replacing collets. Collets are one of the most overlooked accessories in CNC tooling. When I put the 3/8 bit into the collet, you can see there's some slop. I can wobble it around. If I had an ER32 collet nut, as I began to tighten it, the spring steel would begin to enclose around the shaft of this bit, therefore securing it in place. Something to consider. If you look at the end of this collet, there's spaces. So even if I tighten this down as tight as I could, there could be small spaces in between where the surfaces are in contact with the bit. I mentioned the lifetime expectancy of the spring steel. So we just talked about there being possible small spaces in between where the surface contacts the bit. Well, as this spring steel gets weaker and weaker, those spaces begin to grow. In those spaces, the tool is not secured or supported. With a brand new collet, the spaces are very, very small, which is great. Our tool is going to have great tool life. As the spring steel begins to weaken on a collet, those spaces become larger and larger. Just like I showed you earlier, if I put this bit into the collet, there's some slop. It can wobble around. That is usually referred to as vibration while you're cutting. The more vibration, that means the more your tool is moving. That has a significant impact on tool life. Just like I showed you earlier, the more space, the more wiggle. When this is under pressure, you're probably not going to be able to tell that the tool is wiggling. However, when you spin the tool at 18,000 RPM and something's off balance, it begins to wobble. At high machining speeds, we refer to that as vibration. The more vibration this tool experiences, not only will it get hotter, but it will get hot quicker. Here's something interesting though. This collet is way less expensive than this tool. Typically, somewhere between a half to a third, maybe even more, of the price of this tool. We talked about the two different types of tool holders, the isocone or sometimes BT, and also the HSK tool holder. Both of those styles are collet tool holders. However, both are also available in other styles. There are two styles that I'm going to be discussing. The first is heat shrink. The second is hydro grip. They're actually both very similar, but let's start with heat shrink. Now, heat shrink is just like it sounds. You use a machine to heat up the body of the tool holder, it expands, you insert the tool, and as it begins to cool, it secures the tool. Then there's a trade-off. For every diameter of bit you use, you have to buy an individual tool holder. This could be seen as an advantage or a disadvantage. The advantage is that I don't have to buy collets anymore for the life of the tool holder. The disadvantage is that tool holders are more expensive than collets. If you watched my last video with Kurt from Simpatico, they use heat shrink tooling. I'm going to say that heat shrink came out around 10 years ago, and Kurt's always been on the leading edge of things. While there's a trade-off with collets, there's something that's a little bit more difficult to overcome, and that's the heat shrink machine itself. You need a machine that heats up the body of the tool holder. In recent years, heat shrink machines have become more affordable and therefore more available. They used to be cost prohibitive. Therefore, people would send their tools and their tool bodies off to a manufacturer, have them exchanged, and have them sent back. Heat shrink machines can vary widely in prices, from a few $1,000s to many thousands of dollars. Speed has the most impact on the price of a heat shrink machine. Essentially, how long would you be willing to wait before you could exchange your tools? This is a hydro grip tool holder. The inside surface of the tool holder is 100% in contact with the shaft of the bit that's in the tool holder. Now, it doesn't have the downside. I don't have to worry about sending off my tool holder or buying an expensive heat shrink machine. I mentioned that the hydro grip does have the similar downside to the heat shrink, where you have to buy an individual tool holder for every diameter bit that you own. There is another downside. They're expensive. Some people choose to outfit their entire CNC with nothing but hydro grip tool holders. However, there's an alternative. Hydro grip tool holders are most effective at limiting vibration of tooling. This is most important when you're doing intricate work on a CNC, like cutting MDF doors. For this reason, whenever I have a customer ask me for a recommendation, I recommend that for their door bits, they use a hydro grip tool holder, but for their other bits, they stick with the standard collet style tool holder.